Hi everyone. In today's video, we're going to go over the answer key for problem set 1. If you received any feedback from me in Canvas regarding an incorrect answer, or you'd like a little bit more of a thorough explanation about a particular problem, you've made it to the right place. So let's start off with question number 1. Identify the independent and dependent variables in the scenario below. Additionally, determine whether the scenario represents an example of descriptive or inferential statistics. And so starting off with our first bullet point here, examining whether age in years is related to support for mandatory minimum sentencing laws among adults in the United States. And so a couple of things here. In these examples, we are going to have one primary independent variable and one primary dependent variable. However, just know that when we are dealing with actual research questions in our social world, we could have far more independent or dependent variables depending on the type of question we are asking. Again, for this scenario, it's really just an exercise for you to figure out which one is which, but just know that there could be and often is more than one. And so in this case, our independent variable is always going to be what is possibly exerting an influence on our dependent variable. And so the way I like to think about this, especially when we only have two variables at play, is which one is able to affect the other. And so the two variables we have here are age, measured in years, and then support for mandatory minimum sentencing laws. Just to keep in mind these two variables, one thing that I noticed on quite a few of your responses, and something I definitely made a note on if you had this, was specifically the variable here is support for mandatory minimum sentencing laws. If you just said mandatory minimum sentencing laws, that is incorrect because there's no way for us to actually measure mandatory minimum sentencing laws. Specifically, it's whether or not an individual supported the use of mandatory minimum sentencing laws or not. And so, knowing that those are our two variables at play here, so age and support for mandatory minimum sentencing, we can ask ourselves which one is exerting an influence over another, or what are we hypothesizing that it possibly could have? Our independent variable is going to be that exerts that influence on our dependent variable. And so with those two things in mind, does age actually affect support for mandatory minimum sentencing, or does support for mandatory minimum sentencing laws affect age? And in this case, we know it's only one-way scenario, right? Whether someone supports mandatory minimum sentencing is not going to actually affect their age. We are wondering whether their age affects their support for mandatory minimum sentencing. And so in this case, our independent variable is age, and our dependent variable is support for mandatory minimum sentencing laws. The second component of this is to determine whether or not this is an example of descriptive or inferential statistics. And so keep in mind that descriptive statistics are our most simple type of statistics that we have available to us. We simply describe a group or a sample, and there's no additional statistical inferences that we have to make in order to assess our data. In this case, though, we are examining whether age in years is related to support for mandatory minimum sentencing laws among adults in the United States. So we are extrapolating to a broader population. So in this case, we are using sample data to make inferences or test relationships about a broader population. In this case, it's adults in the United States. So this is an example of inferential statistics. Moving on to our second scenario here, analyzing if there is a difference in the hours spent studying by gender among a group of your friends. And so we can do that same exercise we just did with the first scenario. We need to first identify the two variables at play here. So let's go back to our example. Analyzing if there is a difference in the hours spent studying, so that's variable number 1, by gender, and that's our second variable. So now we can ask ourselves, is hours spent studying exerting any influence over someone's gender, or is someone's gender possibly exerting an influence over the amount of time they spent studying? In this case, we know that our variable of interest here, or our independent variable, is gender. We're assessing whether or not someone who is male or female has a different amount of time spent studying in this particular example. And so we know our independent variable is gender, and our dependent variable is hours spent studying. The second component here is to determine whether or not we are using descriptive or inferential statistics. And here is where we look at the tail end of this scenario. And you could do the same thing with the one above too. Whether or not you're using descriptive or inferential statistics really comes down to what group, sample, or population we are assessing. And in this case, this is just among a group of our friends. So we can actually measure and describe all of these individuals in the group. We're not extrapolating this to a broader population at like the county or state or even national level. This is a singular group that we could have all of the information from that group included when analyzing this difference. And because of that, this is an example of descriptive statistics because all we're doing is simply describing the average number of hours spent studying among one single group. We're not trying to interpret or infer any broader trends or statistics based on this information. Moving on to question 2. Here's where we move into the various levels of measurement. So nominal, ordinal, and again, for the purposes of this class, we are combining interval and ratio level variables. Do know that in your book and in other information online that you may see, oftentimes interval and ratio variables are distinguished from one another. But again, the only real difference there is the true 0 point of ratio level variables. And that's not important for the context of this class, so that's why we combine them here. Starting off with our first example, type of crime, burglary, assault, fraud, and homicide. So those are the examples I'm giving you there. In this case, this is an example of a nominal level of measurement because type of crime has categories that are not numerical and they cannot be ordered. So I always like to think of this in the context of like a bar chart or maybe a line chart. And knowing that our variable is always going to go on our x-axis at the bottom, could I change those bars in an order that would still make sense? And in this case, it would. If I put burglary and then homicide and then assault and then fraud, that would make the same amount of sense to us in reference to our y-axis or whatever our measurement is. Let's move on to the second example. Prison security level. So we have minimum, medium, maximum, and supermax. This is an example of an ordinal level variable. Reason being is that this particular type has categories that can be ordered, but there is not a direct scale between them. In other words, there isn't a numerical attachment to any of these variables that would give us any measurable differences. And because of that, we can still order them because we know that a security level that is minimum has less security than a supermax facility. And that would make sense to us in reference to a x-axis on a bar chart, right? We would want to see it in order of minimum, medium, maximum, and supermax so that we could identify possible trend lines or make inferences about our data as well. But again, because there's no numerical attachment to it and we don't know the intervals in between them, they can be ordered, but we can't make numerical determinations between them. Moving on to our third example here, race and ethnicity of a defendant. So I give the various example categories here of white, black, Hispanic/Latinx, and Asian. In this case, this is an example of a nominal level of measurement because it has scores and categories that are not numerical and cannot be ordered. In other words, there isn't any ranked order that has an inherent value when it comes to race and ethnicity. So that's why it's a nominal level. Moving on to the amount of stolen property in dollars. And so we have a direct measurement here. That is why it is an interval ratio level of measurement, because knowing that it's measured in dollars, This has values that can be ranked and the distance between those values is known. And so if someone stole $1,000 worth of stolen property and another individual stole $2,000 worth of stolen property, we know that the difference there is $1,000. It's measurable, and we know that that second individual stole more in the amount of stolen property than the first. And so again, this does have a numerical attachment. It can be ranked, and the distance is measurable and it is known to us. Moving on to risk level for reoffending. Low risk, moderate risk, and high risk. This is an example of an ordinal level variable because, similar to our example above about the security levels of prisons, it does have categories that can be ordered, but there isn't a direct scale between them, nothing measurable like the previous example about the amount of stolen property in measurement of dollars. And so it still has an inherent order that would make more sense to us if we were to order it accordingly to low to high, but we can't measure anything directly from it. Last example here for level of measurement is age of the victim measured in years. This is an example of an interval ratio level variable. It has values that can be ranked, and the distance between those values is known. So we know that an 11-year-old victim is 6 years younger than a 17-year-old victim. And so again, that's something that we can measure. We could have any example in that scenario and know that the measurement and increment between those, or in other words, our interval, is a year at a time. And so there is a measurable distance for us. Moving on to question number 3. This is asking you to identify the appropriate type of analysis, whether it is univariate, bivariate, or multivariate for each research question listed below, and explain why this analysis is appropriate for that question. Starting off with our first example here. Is there a relationship between an individual's gender and whether they are arrested during a police stop? And so to determine what type of analysis would be appropriate here, essentially what we have to do is identify the number of variables that we are working with. So let's take a look at this example. Is there a relationship between an individual's gender? So we have one here, and whether they are arrested during a police stop. And so I see 2 variables listed here. So that indicates to me that we would be performing a bivariate analysis because we are analyzing 2 variables simultaneously to determine if there is an empirical relationship between them. In other words, does an individual's gender affect whether they are arrested during a police stop? So those are 2 variables of interest, and we're only comparing those to each other in this scenario. So bivariate is a way for you to know that bi is 2. So a bivariate analysis is appropriate here. Second example, what is the most frequently reported type of crime in St. Louis during 2024? And so again, all that you're doing here is identifying how many variables there are of interest. And even though there could be various types of crime, as we saw listed in previous examples as well, we could have assault or burglary or robbery or homicide. The only variable of interest here is type of crime. It doesn't matter how many types of crime there are, but we're only measuring one variable here. That's why we are using a univariate analysis, even though we know there could be a lot of different kinds. Last example here, how do age, prior record, and employment status influence the likelihood of recidivism among formerly incarcerated individuals? This is an example of a multivariate analysis because we have multiple independent variables here in reference to a dependent variable. And so anything that's going to be multivariate in nature is just going to be anything that exceeds 2. So anything beyond a bivariate analysis will be a multivariate analysis. So I see here that we have age, prior criminal record, employment status. Those are our 3 independent variables here, and we're looking to see if they have any influence of the likelihood of recidivism among formerly incarcerated individuals. So our dependent variable is likelihood of recidivism. And so with all of those things in mind, hopefully you have a better understanding of what this problem set was really getting at here, just getting familiar with how to interpret data, how to label it, and know what we're really working with here. If you have any questions about any of these particular questions within the problem set, please feel free to stop by my drop-in hours or feel free to send me an email as well. I am more than happy to meet with you one-on-one if you have any questions about this or concerns or anything with regards to your in-text comments as well that you might have a concern about. I'm happy to answer questions about that. Otherwise, if not, I will see you in the next review video.